We are the team Your Major Tom. Our goal is to retrieve Martian rocks. The closest sibling of Earth is Mars. The similarities between the two planets is striking. Mars once had a vast ocean, and right now, there are still underground lakes present. All the similarities provide humanity to study Mars in much more detail. We have been doing this through rovers. But there is a limit to how much information rovers can give us, because the onboard scientific apparatus is also limited due to the weight and dimensional requirements. So we need to find a way to recover rock samples back to Earth. This way, the more advanced labs can examine these samples in much more depth, increasing our knowledge about Mars.
In order to recover samples back to Earth, we have designed a rock retrieval system that will identify rocks and retrieve them by placing them in a tray capsule to be collected in future missions. Our design for the rock retrieval system consists of 3 devices: the OpenMV H7 camera for rock detection, MATLAB programming from a computer to send commands, and a UR5 collaborative robot for retrieving the rocks. The workflow of the system starts with processing image data from the camera feed. The microcontroller attached to the OpenMV camera has a Python-based source code that analyzes and detects desired objects from the images. That information, including coordinates of the detected rocks and their sizes in pixels, are then sent to the MATLAB source code on the host computer for further processing. MATLAB then transforms the received data into actual positions of the rocks and sends commands to the UR5 arm based on those locations. The UR5 arm will then move to those positions to collect the rocks and place them into a tray capsule one by one. The image shown on the left side is the view from the OpenMV cam, which we can see is in grayscale. OpenMV draws a rectangular frame around the rocks that it detects. Image on the right side shows how the microcontroller processes the camera feed based on the preset threshold, where the rocks that fall within the threshold are converted into white and the surrounding area is black. Only white pixels will be tracked by the OpenMV.
The starting point for picking up rocks was moving the UR5 arm to a scanning position that allows the OpenMV to see if any rocks can be picked up and put in the tray capsule. Therefore, the OpenMV would need to be mounted directly onto the gripper of the UR5 arm. If any rocks' positions had been determined, the relative positions of the rocks need to be calculated with respect to the base so that the arm could be moved to above the rock. Once the position of the rock relative to the base had been determined, this new position was sent to the UR5 by MATLAB via a TCP/IP connection. The arm then picked up the rock and moved it to the tray capsule where the rock was deposited. The arm then moved on to picking up the next rock until all of the rocks had been collected.
Our rock retrieval system was able to well identify multiple rocks in our terrain and place them in a tray capsule. This tray capsule is to be retrieved by a future mission. Future work includes testing it on a much more accurate Martian terrain and mounting a range detection subsystem. This way, the position of the rocks can be determined much more accurately. There is a long way to go to perfecting this, but once you do, it will propel our knowledge about our closest sibling.